There's lots of different softwares available out there that can complement the electron microscope. But just to show you how easy it is, even for the most simple tools, Media Cybernetics Image Pro software is actually very, very nice and has lots of different kinds of measurement tools. And here is just a few just to kind of show you here for just doing manual measurements. I know some people tend to refer to free software, open source software, things like that, in order just to do circles and lines and just grab a quick measurement, or even on screen with their very own EM GUI controlling software. But there's so much more that's available, but yet still very easy to use. So in this example, if you look at the image here on the right, it's a DRAM chip. I went ahead and sectioned this by the Hitachi Ethos NX5000 SIBSEM top down in order to get more of a profile along these long, tall via structures that are there. And what I would like to show you is just a couple simple different ways of how to measure this. So here I have the screen. This is Image Pro. And there's several tabs at the top, but simply enough, we just want to measure. So here's our circle tool. We see circle structures on the micrograph. So let's try the circle tool. For most people, this would tend to be the first kind of tool that you would go to. So what we can do is zoom in. Let's find a region of interest. And then we can click right on this corner here. Get that. And then try and draw a circle in order to measure it. Now, obviously, in reality, it is not as circular as this circle function would be. So let's try the ellipse tool instead. And for this is going to give us a much closer measurement, and you can see the value on the bottom left. We'll show you the area for that instantly. But one of my favorite tools is the Auto Trace polygon. Very, very flexible tool. You'll see the menu for different properties pop up on the right side. But you simply click once, you click twice, and it'll automatically gravitate towards that contrast edge. Now I'll do the outside. Click once, click twice, and then it'll auto trace. And this will give us a much more granular measurement that we can go by. Now I'll just go ahead and pull up the measurement table here. And we can see all of our different measurement objects. Plus, the more we process on this image, the more of the values will generate for the mean, standard deviation, minimum, max, things like that. On the types, there's different types of measurement variables that are available. So I'll just scroll down here so you can kind of see the extensive list. There's so much more, but right now, since we're working on circular structures, we already selected the area. So let's see what else we can click here. Okay, we'll try that for the region diameter, and let's go with the diameter mean. So once I double-click those, it'll be in the list, and as soon as I collapse the menu, they instantly populate. And that's one of the nice things if you have multiple objects. You don't have to redraw those measurements. You can just simply select the measurement type and have it all in the same software, same interface.
Just giving another example of some of the tools available for the manual measurements. As you can see, there's a range of manual measurements direct. We can do all-max snap to edges. But in this example, coating thicknesses, layer coatings. I mean, it could be, this is a coated material, but it could be thermal spray coating, coatings on, for example, a stent. We do work with paint manufacturers, different coatings where they're taking cross sections and looking at different layer thicknesses. So in this case, feature called incremental distance. This is just an example. There's a couple ways of doing this, but in this form, it's simply defining a layer, define the edge of it, and define the second edge. And what this will do through this feature called incremental distance, I can choose the sampling of how often I want to take a sample across that particular coating. It'll automatically generate mean, max, min, and standard deviation, so I can choose how I'm sampling it across. Again, then I can do multiple layers, but it's a very nice and efficient way of doing coating or layer thickness using the tools, using the basic tools, in this case, built right into Image Pro.
So on this one is he talked about the layer thickness measurement, but as a different example, especially for fabricated structures, we could do line profiling as well. So instead of measuring the two edges in contrast line in order to find the thickness, it could be simply just the interface themselves, and that's what this provides. In addition to that, we can do point-to-point. There's your simple line measurements. Of course, I showed you the auto-trace polygon, but of course manual tracing for the polygon in order to obtain area, intensity, width, height, roundness, diameter, volume, things like that. And things such as circuit boards or infiltrated composite materials with glass fibers, then you have the circle measurements as well. So the idea here is that, there's a multitude of different ways that can, to take a micrograph and measure it, depending on the kind of application that you have. So of course, Image Pro does provide these kinds of basic measurement tools.
Moving on to some of the more advanced features, 2D automated analysis. And there's a range of capabilities here. And you'll see the outcome of this in a moment. As I mentioned, machine learning. This is another methodology for segmenting or identifying your objects or areas of interest. Instead of a straightforward intensity thresholding and segmentation to define the areas you want to measure, with machine learning, we're training Image Pro to recognize your objects from the background. And it could be different types of objects, but in this case, simply defining your object and the background to automatically segment your objects of interest. The beauty of this and the real importance of this is it really leads to a much more robust identification of what you're trying to measure, where it becomes invariant to different shading. If you have some shading across your sample, for instance, and that may be changing as you're acquiring from different locations on your material. The thing about machine learning is you can train it to recognize only those areas where you run into problems with intensity thresholding. What's also really important about machine learning is you can train off of multiple images, because one image may not be representative of your whole experiment and some of the different imaging conditions you may see. But being able to train off of multiple images, you can then build that recipe in machine learning to be able to properly identify and measure across multiple images. And that's really the importance and the power of machine learning. Once you've identified your objects or your areas of interest, in this case, these are ceramic particles, characterization. There's hundreds and hundreds of parameters that you can just, area and diameter is a simple example that you can use to characterize your sample, whether it's texture-based, morphological-based, or intensity-based. There's a range of parameters, again, that you can then report those out for each and every object. In addition, and importantly, there's a whole range of classification available to you, from a very straightforward, I want to do a size distribution analysis. I want to classify by a single parameter, a single measurement type, for example, area, or in this case, maybe roundness. They've already segmented, but I really, for a particular SOP or a particular workflow, I want to know the distribution analysis of my particles. And it's very easy to set up, that you can repeat that over and over again as a standard operating procedure, that you're doing a QA, that I want to report the distribution of my particles by size and setting up those bin ranges. As I mentioned, machine learning is useful in training Image Pro to recognize what you want to measure, but it can also be used in classification, especially if you have different classes of objects that are very similar in their properties, maybe same size, but they have slightly different perimeters, slightly different edges, maybe slightly different textures. In this case, you can use machine learning to actually create a feature called learning classification, that you can use machine learning to train the software to recognize these different categories, which would be possible to do by a single parameter, single measurement type. So again, this is a sophisticated machine learning to simplify your classification and make it very robust. Again, you can train off of multiple images to generate that recipe to classify your objects of interest. And again, once you've done that, this can put into an automation routine where you can batch process, because usually sometimes it's a one-off, but if you're processing multiple images from a sample, you can set up to do an automatic routine to process tens to hundreds or thousands of images and generate all that data and then accumulate all the data right within Image Pro, that we can accumulate that instead of having to export for each image, but we can keep the statistics from each image and then combine that and report out the statistical analysis result from analyzing multiple images.
So for the advance on 3D visualization, there's also 3D measurement. Earlier I talked about 2D tools, lines, circles, polygons, things like that. Image Pro, what's really nice is that you don't have to relearn a new software, a different interface. It's the same software, it's the same interface, and things are a lot more straightforward. So essentially the same action that's done in order to produce a line measurement or a circular measurement, those same techniques can be applied but in 3D space instead. And that's what this shows here. You can even take a 3D flight series segmentation set, and we'll have an example to show in a bit later on with that. But you can still use a 2D space even though it's a 3D data set. And that makes things a lot faster, a lot more straightforward in order to manage the different measured objects while you're observing on the software. And then here on this data tree, if you look at the 3D view, it's a very, very straightforward tree that goes from a priority top to least minimum bottom as far as its order, and you can click and drag in order to have either an iso surface of a particular segmented object as the priority or not. For the video studio, this is also incorporated into the 3D plugin of Image Pro. So that way you can take your 3D object and record that, so that way it's presentable either to your other colleagues or for upper management for reporting cases. What's quite useful is that they're non-proprietary formats, so you can produce as any kind of Windows type of codec, whether it be WMV or AVI, or of course the traditional MPEG or MP4 compressible type format. What's really nice about this too is when I use this to process my 3D series set, oftentimes generated from the FibSim, and I have a certain motion, pan, and zoom that I would like to produce, those motions can actually be saved independently of the movie. So if you have different data sets, you don't have to start from scratch. You can use those same motion sets that are saved and then apply that to a different data set to give you a very similar rendering when you do your movie. For the reporting and sharing, there's lots of quick reports, and they are exportable to several different kinds of formats. Here you can see that they're MS Office friendly. Of course, you could keep it in the Image Pro format itself, should you have a network license or expand to multiple licenses in your lab. PDFs as well, which is quite friendly for email, and HTML. There are customizable templates. So essentially you can import all the data, generate the data, analyze it, measure it, and then click a button to lay everything out into a proper format quite easily using this software. Especially when dealing with multiple data sets or large data sets, it gets pretty challenging in order to summarize all of that information into one page. And the quick reports really do help in order to tabulate that information. So that leads me to the variable pressure models. On the left side, we have the Tabletop 4000. We also have the FlexSim 1000. So these are how should I say, friendly systems for people who are just starting out in EM or electron microscopy, or first-time users, especially when it comes to graduate or undergraduate level type of work. These machines have been very popular in those types of fields. Plus, they're very portable as well for those kinds of applications that require mobility, especially for oceanographic types of applications. But for those who are into bulky, non-conductive, geological, or even metallurgical types of applications, the SU-3800 or the SU-3900 large chamber front opening variable pressure type of tungsten tool would be much more suitable for that kind of work. And then, of course, for those who actually need nanometer scale imaging, but yet still carry variable pressure type of capability, the SU-5000 and the SU-7000, which can do sub-nanometer or even just a couple nanometer type of imaging resolution compared to the tungsten tool, kind of open up and broadens the application for EBSD, EDS, WDS, CL work, STEM imaging as well, not just secondary or backscatter, but lots of other different kinds of signals. So, you know, some of the following examples are going to show, you know, how that applies. So, example of an application or an app. This is electrospun material, and again, with a simple setup, go ahead and start playing. With a simple setup, and this handles, you know, bright fibers on dark background, and reverse, it can handle second electron or backscatter. But by following a simple setup, it's easily to identify your fibers, go through choice, and now here's finding the thickness of the fibers. Again, having that statistical information where we can report, again, also a batch process, min, mean, max, standard deviation, so you can characterize your fibers. This will also report fiber orientation. Again, with the various displays as you're characterizing your manufactured materials, you can then come in and take a little bit of a deeper analysis about those materials and their characteristics, you know, from the manufacturing process and then doing the QA. Next slide. As we talked about, ceramic particles, about machine learning. Here's a very straightforward example of showing how machine learning works and how this can be used. Go ahead and start, if you would, please. We're simply using, we call it smart segmentation, but this is machine learning where we can come in and train off of an image or multiple images to identify your, in this case, the ceramic particles of interest. We can simply define those. We're training it, defining the background, and then with a little bit of cleanup, we can do this. Again, this is really great if you have some variations, some shading. We count, we find all of our particles, and you know, if this is what you're doing at this level, this would be fine. But in this case, if you want to characterize your particles, this is where we call it single parameter classification. We can set up a size range that you're doing some standard SOP in a quality assurance process where you're pulling a sample every so often, and then you can report out those statistics. So it's really nice in the building capabilities. It's not just how many particles in each class, but we can also get the statistics so you can take a deeper look at what's actually occurring in that material. Again, we have different views that you can actually report out and then put into a report, into a PowerPoint, the results of your image analysis or results of that experiment or of that QA process. Next slide, please. So, you know, those are a few typical kinds of examples that you would see on that class of electron microscopes, whether it's a field emission, nanometer scale kind of imaging, or even variable pressure side for non-conductive material. But how about if we take a look at FIB SIMs as well? So here, just to kind of give you an idea of the different ranges of FIB SIMs that Hitachi offers, we have the NX2000, which is a 200 millimeter wafer-capable FIB SIM. There's the NX5000 or the Ethos NX5000. This is our latest generation large chamber FIB SIM. It's actually designed in order to accommodate different kinds of devices, detectors, by having a very tall main chamber which can be retrofitted or equipped with a cold stage, cryo stage, air protection, as well as EDF, EBSD, lift-out system, multiple gas injections, and as a 2-column or a 3-column type of FibSim. In fact, all 3 of them can be either a 2-column or a 3-column type of FibSim. And then for those that are into dedicated series sectioning, which tends to be a bit more into advanced materials in the biological side for, SBF-based applications, or should I say serial block face type of imaging, that's the NX9000. For this, we have both columns, which are 90 degrees apart or orthogonal, and that helps to alleviate those typical V-shaped artifacts that tend to occur when it comes to slicing and imaging by keeping the E-beam normal incidence to the imaging plane. So there's no shadowing effects. You don't have the foreshortening to deal with, or sometimes you end up with the electron trap, and you have a very poor signal to noise when it comes to imaging and detecting as you're slicing in a large trench across your bulk sample. So the NX9000 tends to take care of that. But the fact is that, most people tend to correlate segmentation with FibSim, which is great, and ImagePro is compatible in a 3D sense to that, but it can also handle 2D applications.
So for an example of FibSim using the NX5000, what you're going to see is a root tip and looking at plant cells for a biological example. And so in this case, we're going to really highlight the major 3 capabilities when you're doing FibSim and want to analyze that data. If you go ahead and start, please. So this is a FibSim, so we have those planes, that serial block face. As you can see, as we're going through this, in calibrate, but this shows also the moving making capability and having the different views so you can look inside your material with these different clipping planes. And then being able to segment and identify, in this case, the cells in the plant root tip, and then doing that analysis. But it really gives you the power to look deep inside your sample by using FibSim and seeing those structures. And there's a number of examples. We're looking at a NAND memory block, being able to look deep inside that material, into that device, and seeing how things are spatially aligned, and or if you're looking for defects, quality assurance. But again, this just shows and highlights being able to take that stack, generate your 3D rendered volume, do your analysis, and then make a movie for, again, presentations, whatever you need that movie for, but to demonstrate that particular experiment. Next slide.
So the fact remains is that with ImagePro and Hitachi, there's numerous types of different applications, more than what we can show you now. It's really just to highlight the capability of bringing these 2 technologies together. Whether you have a variable pressure SEM, a field emission FEM, a FibSim, or even TEM or SEM type of microscope, all of these things are auto-calibrated and can interface with ImagePro. The other thing, if you haven't picked up, is the fact that we can process images, measure those images, and represent that data in a visual format, whether it's a bar chart or if it's just outputting statistics. And it's all the same software. It's all the same interface. I've encountered a lot of different labs and researchers that tend to use one software for one particular aspect and a different software for another aspect. ImagePro gives you all of that capability all in one interface. So that way, you only need to learn one type of software and you're done.